Hi everyone, today we're learning about systems of equations. So a system of equations is any time that there is two or more equations. So two or more equations, that is considered a system. Today we're going to work with mostly two equations. So there are sort of three different situations we can have. The first is where one line comes in and the other line comes in, and these are called intersecting graphs. So we learned about perpendicular on Tuesday. That's when they come together at exactly 90 degrees. Those are also intersecting graphs, but intersecting by themselves just means that they touch in any way. So could look like this, or could be like this. However it looks, as long as it touches one time, they have one solution. And that solution is right here where they intersect. Right, so their one solution would be right here. Another situation we have is when two lines are parallel, which we learned about on Tuesday. If it's parallel, that means that they never touch, so there's no solutions. There's no solutions because they're never going to touch, so they can't possibly have an intersection. Right, so these graphs would have no solutions. And then we have our third situation where we have what looks like one line. This is actually two lines on top of each other, right? So one line going like that, another line going like this, right? These are called infinite solutions. Or we say that they have infinite solutions because a solution is anywhere where they touch. So they touch here, 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 forever and ever and ever they touch. So they have infinite, like as many as you can think of, and then more than that. So these are our three situations: intersecting, no solution, and infinite solution. Or one solution, no solution, and infinite solution. It is possible to have two solutions, but not with straight lines, not with linear lines. So let's say we had a parabola and a line, then we could have two solutions. But today we are just going to have, we're just going to stick with linear. So we'll stick with two straight lines. Okay. So there are 4 different levels, or 5 different levels actually. We're going to start with just level 1, and then honors you'll stay for level 4 and ACC for level 5. So let's check it out. In the first level, we're just graphing in slope-intercept form. So graphing like normal. We're going to start at +2. I'm going to start at +2. And my slope here is 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Like this. Draw that line straight through. Want to make sure that I draw it super straight in both directions. Like that. And then I'm going to go ahead and draw my second line as well. So -2, where I'm going to start, and up 2 over 1. Up 2 over 1. Up 2 over 1. 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. So I can see that line going straight through there, just like this. And I can see that they touch at this point right here. So I'm going to go ahead and count. I'd see, okay, it's 1, 2, 3, 4. So 4, comma, 1, 2, 3, 4, 5, 6. 4, comma 6. This would be the solution, right? It's the place where the two cross their intersection. So this point right here would be the solution of this system. So that's level 1. Just graph the two lines, right? Graph the two lines and then find where they intersect. Okay. Level 2, go ahead and pause the video if you need to write down these problems. All right. So in level 2, I can see that the problem is in standard form, right? This one is in standard form. Since it's in standard form, it's not so easy to graph it. So I'm going to go ahead and write it down. X plus y equals 1. I want to get y by itself. So since I want to get y by itself, I'm going to get rid of x over here. So I'm going to subtract x on both sides. So y equals, And then x and 1 are not like terms, so I'm going to write negative x plus 1, just like that. Put the x first, so that's an mx plus b. So when I graph this one, I'm going to start at positive 1. And remember that slope is like negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Just like we have been practicing. So we're getting some good graphing practice here. So plot that way, this way as well, just like this. And then for my second one, I have x equals 3. Remember that I'm going to go on the x-axis to positive 3. So I'm going to go on the x-axis to positive 3. And then this would be a straight line up and down, just like that. In order to find my solution, I'm going to go to where they intersect, which is right here. So my solution would be from the origin 1, 2, 3, 3, comma, negative 1, negative 2, 3, negative 2. I usually don't put those lines on my graph. I'm just showing you how to get to my solution point. Okay. So that is level 2. We're going to try level 3. Level 3 looks like this. Ooh, getting a little crazy, but not too crazy. So I have this first problem. I want it to be in y equals mx plus b, so I'm going to go ahead and write it down. X plus 2y equals negative 8. I want to get y by itself. So I'm going to go ahead and get rid of x first by subtracting on both sides. So I have 2y equals negative x minus 8. I'm going to go ahead and divide by 2. Divide everything by 2. Gives me y equals, I'm going to put that little negative 1 there because that's going to help me make negative 1 half x. Right? I'm taking that negative 1 that's sort of imaginary there and dividing by 2, negative 1 half. I'm going to leave it in fraction form so it helps me with my rise over run. And then negative 8 over 2. And 8 divided by 2 is 4. So I'm going to go ahead and simplify that. 4, like that. So I'll go ahead and graph my green line. I have negative 4. Going down 1 over 2, down 1 over 2, down 1 over 2. Up and backwards. Just like that. I'm going to go ahead and draw my line. Thank goodness for technology, drawing my straight lines there. Just like that. I'm going to do the same thing for this purple one here. X plus y plus 3 equals 0. Again, I want to get y by itself. So I'm taking the x to the other side. Y plus 3 equals negative x. I don't need to write that 0 anymore. I could put plus 0 here. Not going to hurt anything, but it doesn't really help us. I'm going to subtract 3. Say, okay, y equals negative x minus 3. So I'm going to start at negative 3. And remember, this is negative 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. I can sort of stop when I get to a place where they intersect, right? I don't really need to continue that. I want to draw my line, but other than that, I don't need to draw too many. So I have that point. I can see my solution is at positive 2, negative 1, 2, 3, 4, 5, negative 5. So that would be my solution. Okay. If you are star, 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 or on track, regular, this is the end of your notes for today. If you're honors, I want you to go ahead and stick around for level 4. Level 4, take a second to write this down. All right. So I have 4y equals negative 2x minus 12. I'm going to go ahead and divide by 4 on each one. Y equals negative 2/4. I know can simplify to 1/2, so I'm going to do that now. And then minus 3. I'm going to go ahead and graph that super quick here. Awesome. I'm going to go ahead and graph this next one. I'm sorry, solve for this next one. 6y equals 3x plus 6. Dividing by 6, y equals, I know 3/6 also simplifies to 1/2. So I'm doing this, plus 1. So I'd have positive 1. Going up 1/2, down and backwards. I can see where those points are going to intersect. I can draw this quick line, draw that red line real fast. You can see if I don't draw very nicely, then I'm not going to be able to tell what number I have, right? So I'm going to go ahead and go back and try to draw it a little bit better this time. Be a little bit harder to see, but I know for sure that we overlapped at this point here, which is at -4, -1. So not too much more challenging, except we had to simplify some fractions. So you guys should be good to go for my honors students. For accelerated, you have one more set. So accelerated, we're gonna do this one together. So honors, you're done. You don't have to take any more notes unless you want to stick around for this one. Accelerated, we are also working on inequalities today. So I know you know this and probably remember this from class, but if you have less than or greater than, remember that this is like your open circle or your dashed line. If you have greater than, less than, or greater than or equal to, or less than or equal to, you have the solid line. And so just a quick reminder on that. Also, if you remember that if you have less than or equal to, you shade down. And if you have greater than or equal to, you shade up. So this is your shading. Right, so just keep those in mind as we're doing these problems. I'll start with this one. I'm going to do exactly the same thing as I was doing before, which is just get y by itself. So I'm going to add 4x to the other side. Y is less than 4x minus 4. So starting at -4, going up 4/1. Sweet. I see that this is less than, right? It's just less than there. So it's going to be a dashed line. So when I draw it, I'm just going to go ahead and draw it like this. And since it's less than, I'm going to pick one of these points and shade down. Pick one, shade down. Pick one, shade down. One, shade down, like that. You might see some people like do it like this, which is also beautiful. Sort of like a little bit of coloring action here, which is awesome. Cool. So you have that nice easy line there. And then we'll do this next one. It already is in slope-intercept form, so we're good to graph it. So I'm going to start at +10 and sloping down 2/1, down 2/1, like so. I can see that it is again like an open circle or a dashed line. I'm going to go ahead and draw that dashed line through here, like so. And this one is also shading down. So I'm going from each point, I'm shading down like this. It's a little harder to tell with those lines, so I'm going to go ahead and use that like shading. I'm shading on this side here. So this whole thing, little coloring here. Perfect. Okay, so we have the purple line that's being shaded down, and we also have the orange line or pink line that's being shaded down. Right, so since both of those lines are being shaded down, there's a place where they intersect, their intersection. So that would be like this section in here, we would consider the solution set. So what we would write is you kind of do this and you write the solution set. That means that this is a solution, this is a solution, this is a solution, this is a solution. Any point that's inside of there is a solution, even one that's like way up here or in the corner or off the graph. All of those are solutions. This is not a solution, nor is that a solution. Those are solutions to their individual inequalities, but not to the system of inequalities. Okay. You might be wondering, like, okay, how do I get no solution then? Let's say you were drawing a line like this and you shaded this way, and then you had another line that was like this and you shaded this way. This would be how you would get no solution with these, because there's nowhere where they overlap. Right? If you were to have like this line shading up and also this line also shading up, then your solution would be this part, just the top part here, all the way up to that line and then stopping. Right? So that is how you do your second IXL for today. You're only going up to 75 on the second IXL. You're not going all the way to 90 unless you want to get some extra credit. Okay, that's it for us today. Thanks, guys.